In this video, I'll be doing a detailed solution to the maths question you see on the screen here from the Cambridge A-Level Mechanics paper 4.3 from 2024. If you're looking for a different question from this paper or a different paper entirely, check out the description below. And if you find this or any of the other videos on my channel useful and would like to help me out, the best thing you can do is share it with other people doing the exam. Perhaps if you're in a class WhatsApp group, share it there. Failing that, a like, subscribe, or even a super thanks. In question 5, they tell us about a van of mass 4,500 kilos pulling a trailer. Is it up a hill or down? We're going down a hill first of all. And it gives us lots of information. Let me try and draw roughly that. Here's a van and here's the trailer. And they tell us there's a rope, something tying it. Let's just call it a rope for now, tying it together. Gives us lots of information about this. Ultimately, they want us to find the acceleration of the trailer and the driving force of the van. Remember, the van has an engine, it's pushing it down the hill. Let's go ahead and put in some rough force numbers here. Oh, actually, I won't put the numbers in. I'll leave the numbers somewhere later when I draw it bigger. But roughly speaking, we have a gravitational force on the van, pushing it down. We have a gravitational force on the trailer, pushing it down. The van is using its engine to propel itself forward in some way. There's friction. There's friction, air resistance and friction off the ground stopping the van, and there's more resistance stopping the trailer. And the last one, the one a lot of people forget, thankfully they actually told us about this time, they told us tension. There's tension in the rope pulling the van towards the trailer, and there's tension pulling the trailer towards the, bit messy in there, sorry, pulling the trailer back towards the van. There's 3 ways you can often look at these systems. You can look at the trailer on its own, which we will do. You can look at the van on its own, which we will do. Or, and here's the one a lot of people forget, you can look at it all together. You can combine everything. The advantage of combining everything together is the tension disappears. There's no tension when you look at the system as a whole. Now, unfortunately, there's no point doing that in this case because one of the numbers they gave us was the tension, and we're looking for the acceleration and the driving force. We're looking for 2 things. So let's not get rid of the one thing we know just yet. So before I do the maths, let's just talk about what we could find if we looked at the van on its own. If we looked at the van on its own, we would be missing information about the driving force, which would mean we would never be able to find the overall acceleration in this, the overall force giving us the overall acceleration. So that might be a dead end, the van. Now, if we think about what we would get in the trailer, we know the resistance force. They gave us that. What is it there? It's 300 newtons. We know the tension force. It's 450 newtons. We know the gravitational force. That's just 10 multiplied by, what's the weight of this trailer? 750 kilos. We know everything about this trailer, which means we can find its force, which means we can find its acceleration. Also, remember, acceleration are the same of both of these. They're moving together. So let's draw just the trailer, the forces on this trailer. The forces due to gravity is 750 times 10, 7,500. The forces due to resistance, what did I just say, 300 newtons. And the forces due to tension, 450 newtons. We're going to combine this overall, put all these forces together, and then I know all the forces put together is equal MA, and we know M of this, so we can find A. So to do that, we'll leave these 2 alone. They're already in line. So we'll change this guy, break him up. I like to draw a little rectangle. We'll break his force to 1 going down and 1 going into the ground. Don't care about the 1 going into the ground. We already know about the resistance force. This one's useful to find the resistance force. We already know it, so we can ignore that one. We have an angle down here of the theta, this theta angle, and they tell us sine of this is 0.05. So if that's theta, that's 90 minus theta. This one in here must be theta as well. So we're interested in this length, and that's opposite to this angle. So that's why they gave us sine. This force in here due to this gravity is 7,500 multiplied by sine theta, which, like I said, that is 0.05. So overall, the forces on this system going down the hill, we'll say, is 450 minus 300, pushing it back up the hill, plus this 7,500 times 0.05. That's the total force on the system. You can put that into a calculator and we get 525 newtons. So that's, to draw this one last time, overall that's what's happening in this system, 525 newtons. Now we know the force is equal to MA. We know M is 750. What we're really looking for is what's A. So A is equal 525 divided by 750, and that comes out to be 0.7. That's meters per second squared. That's the acceleration in this system. We still need to find the driving force. To do that, we need to leave the trailer. I didn't leave myself enough room here, I don't think. And we move on to the van. Now the van has a gravitational force down here that was 4,500 kilograms, so 45,000 newtons. It has a resistance force of 2,500. It has a tension. The trailer is a lot lighter, but it's still pulling the van back the same as the other way, so that's 450 is in there. And there's some driving force D. Don't know what that is. But we do know overall the acceleration is A. If the trailer is accelerating at A, so is the van. So overall we know his mass, 4,500 multiplied by this, adds up to all these forces. So let's just do that. We'll break this guy up the same as we did before. That'll turn into a force of 45,000 sine theta. So if we put all of these together, we know the answer. So if we put all of this together, going down the hill, we get D plus 45,000, 0.05. So that's those two minus, let's take these away together, 2,950. That equals MA. And M is 45,000 and A is the 0.7. There's only one unknown in this whole equation. Move all of these over this side. And let's see, we'll get D is equal to this plus this minus this. And all of that put together is 3,850 newtons. Okay, let me clear this off and we'll do part B. In part B, similar situation, we still have the same van, the same trailer, but they're now going up a hill. They tell us the driving force of this, and then they tell us the speed of the van at the bottom of the hill, and they want us to find the total acceleration, the acceleration of the fan, and the tension in the tow bar. Now, I was saying earlier, you can sometimes deal with these systems as one whole. That's interesting in this case because, well, I'm going to do it and it's actually going to be really useful. Earlier we dealt with the trailer on its own. We could do that and we'd be missing the information for the tension. We could deal with the van on its own. In that case we'd be missing the information for the tension as well. But what we could do is equate their acceleration. Their acceleration are the same. So we could find the total force of this in terms of acceleration, total force of this in terms of acceleration, put them equal, and we should be able to find T. That's one way to do this question. The way I like to do a question, when you have the opportunity, is we can put these together into one blob of an object. The total weight of this is no longer 4,500 and 550. It is, what are they combined? 5,250. Is the total weight of this. So there's now a gravitational force of 5,250 or 52,500 newtons coming down. There's still the same driving force on this guy. Basically all that's missing now is the tension. We can still put all the other things together.
The same resistance applies as last time. So what were they? They were 300 and 2500. So there was a 300 resistance and a 2500 resistance. We can just add them together. Was that 2850 resistance? And that's it. There's no unknowns here. We can find acceleration of this system easily. It was hard to find the acceleration of each of these on their own because we don't know what t is. But we can find the acceleration of this system. Let's first of all let's get his move this into the plane of the other guys. Again, we know the angle down here. This is 90 minus that angle, so we know this angle. This is alpha in here. So we know sine of that was 0.09. So all the forces on this guy going up the hill, he's driving up the hill, is equal to 9,100 minus 2,850 minus this one, minus 52,500 times sine of this angle, which is 0.09. That's the total forces on this system. We know this to be equal ma. And I know what the mass of this total system is. It's 5,250. We can then rearrange this, just get A is equal all of this divided by 5,250, and that comes out at 0.3 meters per second. That's half of the answer. There's a much easier way to do it. But now we still need tension, so we still do need to look at one of these on their own. You can choose which one. They both are just missing the tension information. I'll choose the trailer because it's one less force. There's no engine on a trailer. So if we look at the trailer one more time, we have a force due to gravity of 7,500 newtons. We have the same resistance force was 300, I believe. And the only thing pulling the trailer up the hill is the tension in the rope. So that's T. Just like before, we equate all these. Let's say going up the hill, we'll have the tension minus 300 and minus this. It'll work out just the same as the others. Minus 7,500 times 0.09. That's the total forces going up the hill. But we know this is equal to MA. And what's M? 750. So 750 A, 0.3. Again, just one unknown here. We just get this number plus this one, and we will find that T is equal to 1,200 newtons. Oh, there's one more part to this question. They want us to find the speed of the van after it's travelled a distance of 375 meters up the hill. So we have lots of information now about it. I think I can squeeze it all in here. We know the acceleration is 0.3. This distance, they tell us, is 375. They told us the speed at the bottom of the hill, or the beginning speed, is 20. That's three things. We can use our equation of motion to find anything we want from that. They want the speed, so they want V. What equation has all this in it? That'd be phi squared is equal to u squared plus 2as. That'd be u squared is 400 plus 2 times 375 times a. I don't think I have that row in my notes, so we'll leave it as that. Combine those and we will get phi squared is equal to 625. That would mean phi is equal to 25. That's meters per distance, the speed. Okay, that's it for question 5. If you have any comments or questions about it, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a good day.